So just somebody please confirm that the slide is visible on your screen.
Yes, sir.
Yes, sir.
Visible, thank you. Okay, just a second, please. So this is the first type of numericals based on the above. Admiralty coefficient, define the admiralty coefficient, define the fuel coefficient, explain relationship between fuel consumption, displacement and speed, calculate daily consumption at service speed, the bunker fuel required for a voyage. So this will be based on what is the voyage distance and when we have to reach there. So that will decide how much power the ship's engines have to develop during that voyage to give you the required speed. And at that power, what will be the fuel consumption? So we can calculate that for the voyage, so much fuel will be required. The speed for a given daily consumption. If I fix up like charterers say, maximum you can consume so many tons per day. So given the daily consumption, I should be able to calculate what will be the speed I will get. And on the basis of the speed, I can obviously calculate what time it will take to complete a particular voyage. Most of it we do it on board as well, so they are directly related to the method which we follow on board. The reduced speed required to complete a voyage with a given consumption. Now this is a factor where sometimes numerical is there based on what is the ROB at a particular moment on board. If during the voyage you take soundings and you find you have so much of bunker, so you should be able to see that, okay, maximum speed I can go with is so and so that I reach port without going into negative. You can't go into negative because then you will not reach the port. So with some unpumpable on board, as we know, every ship has some unpumpable, the bottom oil which is hard to pump. So maybe 5 tons or 4 tons or 7 tons, whatever it is, based on number of tanks. So that means that particular oil I cannot use it. So ROB minus what is the unpumpable is the effective fuel what I have, and on basis of that I can calculate what is the speed at which I should go so that I can make the port with unpumpable still intact. So let us say, then we will also see the role of falling of the hull, because we will see that the falling increases the resistance of the vessel as it moves, and as the resistance is increased, obviously the power required to propel the ship at a particular speed also will be more power will be required if the resistance is more. And that is why you will find in many times you find underwater cleaning or propeller polishing is done to improve the efficiency of the propeller, to convert more power, delivered power or power which is given to the propeller, to convert into thrust power, which is dependent on the efficiency of the propeller. Propeller will work efficiently.
Excuse me. Sir, does
yes.
the shape of the bulbous bow also have any impact on the vessel's fuel consumption?
Yes, it does. See, the bulbous bow, although it would appear that it increases the wetted surface area, as we can see, but it has been found that, and we'll discuss that as well, that the resistance of the vessel, total resistance is divided into two parts. One is called the frictional resistance, which is based on what is the friction between the hull and the water. And second part is, or the component, is the residuary resistance. It is the residuary resistance which increases with speed. That means that residuary resistance can be a major part. Some in high speed crafts, it can be a up to 60% of the total resistance. So that means whereas the frictional resistance does not increase with the same rate. So if the vessel is operating at high speed, we have to take care of the residual resistance more than anything else. And if we can reduce the residual resistance, we can obviously reduce the total resistance of the vessel. So bulbous bow plays a role where the high speed is involved, and there it reduces the residual resistance component of the total resistance.
So the vessels without bulbous bow will have more resistance, right, sir?
See,
Because
as I
I have seen some bulkariates without the bulbous bow.
correct. So that is what I am trying to say. Just okay, let me just explain to you that part. Well, although uh, I would have come to that anyway. There is something called total resistance. Now, if you see here, this is the total resistance of vessel. Now, let us say this is a vessel. Here we have the propeller. Now, the vessel moves because a thrust is created because of the main engine, which is located somewhere here. The power is transferred to the propeller, which creates a thrust, and the thrust power is thrust into the speed. Now, as the vessel moves, it encounters a resistance. That resistance is the total resistance. Now, this total resistance is equal to RF plus RR. These are two types of resistances which the vessel encounters. Now, resistance is a force, and let us say if a vessel is moving, just for example, let us say at 12 knots. That at 12 knots, because the resistance is dependent on speed. So if the vessel V is 12 knots, and the resistance is equal to, let us say resistance is equal to 1000 kilonewton. Force is in newtons, small unit is newton, kilonewton, because we are dealing with higher resistances with reference to the ship. So I am taking an example of 1000 kilonewton. If 1000 kilonewton is the resistance at 12 knots, it also means that if my propeller gives me a thrust of 1000 kilonewton, vessel will move at 12 knots. Have you understood this point? If the resistance of the vessel at 12 knots it is 1000, let us say vessel moving at 14 knots may have a 1500 kilonewton resistance. That means the propeller at this time must be producing a thrust of 1500 kilonewton, then only the vessel will be moving at 14 knots. So that is the first basic concept. Now, as I said, this total resistance is in two parts. One is called a frictional resistance, RF, and second is called residual resistance. The frictional resistance is given by, we have a formula Vs raised to power n, where F is the coefficient, S is the wetted surface area, V is the speed of the vessel, and N is a index. The residual resistance, correct? Now the frictional resistance depends on, as we say, that means it is proportional to the speed of the vessel. More is the speed, more is the frictional resistance. I will come to RR. That is where your answer will be, your question will be answered, because you are saying a bulbous bow. Now, introduction of bulbous bow, we'll see what are the effect of that. So first of all, the first component, frictional resistance, proportional to speed, is proportional to length of the vessel, is proportional to S. S is the wetted surface area, underwater area, in meter square, of course. Proportional to, I am putting proportional to. And roughness of the hull. More is the rough, that means if you have deposits, barnacles and other deposits on the hull, more will be the frictional resistance. So it is, and also on the density rho. So the resistance in freshwater and resistance in seawater is different, and is proportional to rho, means it will be 1.025 times. If I take the seawater density as 1.025, although it may be slightly here and there, we are assuming it is 1.025. So it is proportional to this. That means the frictional resistance will change with speed. That is okay. And these are the factors. Now what happens, since this is not the only factor, we have the second factor also, which is the residuary resistance. Sum of this is the total resistance. I am talking of 1000 kilonewtons or 1500 kilonewtons. Now what happens is frictional, this residuary resistance. So let me just write here RR. RR has got three components. First component is the energy utilized by formation of streamline. Now for understanding, let us say it is a flat surface. That is where the bulbous will eventually come. So as the vessel is moving forward, this is an example of a barge which has a front flat surface, no shape given here. This is the manner in which the streamlines will form. And there, this is one part of the residuary resistance, also called wave making resistance. Wave making resistance. So this is one factor. More streamlines are formed because of the vessel moving at V speed. This adds to the resistance of the vessel, because the streamlines which are formed, the energy comes from the vessel only, or from the ship's engines. So this is one component. Second component is the formation of eddy currents. If you have the change of cross section in the profile of the vessel, let us say, I'm just to make it clear. So these are the eddies where you have the change of cross section anywhere on the profile. So that streamline is another thing. This is eddy current formation. This is the second component of residual resistance. And third is, as the vessel moves, so you have the waves created. This energy also coming from the ship's engines. Combination of the three, that is why we call it wave making resistance. That is called residuary resistance. Total resistance of the vessel is sum of these two. Now comes the actual point. As the vessel moves, when it is at slow speed, correct, as you said, the example of a bulk carrier, which is moving at say 12 knots, as is the example. This part is a very small component of the total resistance. Out of that 1000 kilonewton, this may be only 5% or 10%. That means frictional resistance is the major part of the total resistance. And therefore power required is primarily to take care of the frictional resistance. But if I move it at 20 knots, same vessel or similar vessel going at 20 knots, this 5 to 10%, maybe 15% or 20%, and it has been seen in high speed, it can go up to 60% of the total resistance. That means the frictional resistance is gradually increasing like this, whereas the residual resistance is in a form of a hyperbola. So that is increasing, and it may become a larger portion of the total resistance. So that means if I can reduce this fellow, frictional resistance is linear. So obviously more the speed, more will be the frictional resistance. But residuary resistance is not linear. And if I can reduce this, I can reduce the total resistance or power required to propel the vessel at whatever speed I want. In order to reduce this value, we use the bulbous bow because it interferes with the waves which are created and reduces this component. Although by introducing a bulbous bow, the surface area you will find wetted surface area increases to some extent. Therefore, there will be a slight increase in the frictional resistance, but there is a much larger saving in the residual resistance. So the net effect is total resistance of the vessel actually reduces at high speed. At low speed, no, it does not have much of advantage, except it will add to the frictional resistance if the vessel is. So bulk carriers are not likely to have bulbous bow, but on a high speed vessel, this becomes an important item to add so that this component can be reduced. So this is why it is done. All right, is it clear?
Yes, sir. Thank you.
Yes, sir.
Yes, sir.
Okay. So now let us see. So I'll remove this. So that is why we say, okay. Now this is what the same example which I have said, that if the vessel is moving at 70 knots, 800 kilonewton is the resistance, then if the propeller provides 800, vessel will move at 70 knots. Same thing which I explained to you. The total resistance of the ship is frictional resistance plus residue resistance. Frictional resistance will depend upon speed of the ship. More is, so first component, frictional resistance only. Speed of the ship, wetted surface area, length of the ship, roughness of the hull, and density of the water. Second component, in slow speed or medium speed ships, the wave making resistance is small, and at high speed it is 50 to 60% of the total resistance. So that is the reason why we go for bulbous. Now, if you see the relationship between the power, shaft power, that is the power which is developed at the shaft, although we will be discussing various other types of powers, but if we have the if this is a shaft part and we have the propeller here, and if this is the main engine, so the power at this point is called the shaft power, sometimes called BHP. So brake horsepower, simply because it is calculated by applying brake on the shaft. But this is what is quoted. If you see the vessel ship's particulars, you will find something given as so many kilowatt is the MCR at so and so RPM, at 105 RPM for an example, and we have so many kilowatt CSR at, let us say, 95 RPM. This is what is given in your ship's particulars. Both of them represent the power which the engine is giving at the shaft. MCR represents the maximum continuous rating. That means the engine can be operated up to this value. This is the maximum power. Continuous. That means without exceeding the safe limits. But CSR represents the continuous service rating, which is normally 85% of the MCR value. So this is the power. Now this graph is also with reference to the shaft power, the power developed here, and the speed of the vessel. It is not as, so if you increase the speed, it is not a linear. That means if suppose I was operating at 10 knots and I make the speed double, 10 to 20, power will not become double. Or other way around, if I increase the power from 10,000 kilowatt to 20,000 kilowatt, I cannot expect the speed to increase double. The relationship is in this form, and it follows this relationship. Shaft power is directly proportional to the cube of the speed. So if I increase the speed 2 times, 2 into original V, power will be 8 times increased, correct? So that is why if we see that we are increasing power, we are actually increasing in cubic form the power required to move the vessel, and therefore when the power is increased, obviously the fuel consumption also will increase according to that. So we gain in time, obviously, because speed is more, but the consumption is not directly proportional to that. It is many times more because the power and speed relationship is in cubic form. So that part we have to understand, that it is not that if you increase the speed, the power will change in the same ratio, and the consumption also will vary in the same proportion. No, it will not, because it does not follow a straight line. Fouling of the hull. Now this is what represents the barnacles and which have formed their home on the surface of the hull, and this increases what type of resistance? Frictional resistance, because it has become rough, and as the vessel moves, it encounters more and more resistance. So that means in the relationship where we saw RT is equal to RF plus, this will increase because of the fouling on the hull. And it has been experienced practically, if the vessel remains at anchorage for a long time or in tropical waters, operates more often, and longer port stay. So those type of vessels will have more sea growth, and therefore eventually a stage may come where it will become very uneconomical, and that is why many ship owners go for underwater cleaning, just to reduce the fuel consumption. Otherwise, we'll be just burning fuel and not getting the required speed. So roughness is important, or hull fouling is an important aspect here. This is the diagram which explains that if a vessel is operating with clean hull, this is the graph between the speed and the power. If the hull is clean, this is the condition whether when the vessel has just been delivered, new vessel, or vessel has come out of dry dock after hull cleaning. So it will follow this curve. But as the hull becomes fouled subsequently over a period of time, the curve starts shifting towards left. So let us say after maybe 1 year, let us say, more and more fouling has happened. Now it will be following this curve. So for the same speed, let us say 24 knots as is the example here, the vessel was only developing, let us say 13,000 kilowatt of power was required to move the vessel at 24 knots. But now with the same speed, if I want to get, I may have to develop 18,000 kilowatt of power. Or this is just an approximation, just to understand the concept. So that means my fuel consumption will increase, because from 12,000 to 18,000 I am consuming. So more fuel will be required, and benefit is nothing because I am still getting same speed. However, if I clean the hull, I will start getting same power, or rather at the same power I will get the 24 knot speed, which will save a lot of fuel, and it compensates or overcompensates the money which we spend for cleaning, because the saving in fuel is much higher. So that is why the ship owners frequently go for underwater cleaning in case-to-case basis, depending on vessel, how long it stays in port and how long it stays in tropical waters, etc. Also on the basis of the inspection, the frequency of underwater cleaning can be increased or decreased. So that will be case-to-case basis. But this is a phenomena which is true, and this is how it behaves. All right, now we come to a equation. Let me just use the, or I can use the space provided here, maybe, or let me create a, there is a relationship. Sometimes they ask as a short note just to define it, define admiralty coefficient. So we will like to do that, and I just will add new slide so that we can make use of it. Okay, I will write here. So now it has been established that the total resistance of the vessel, which we have already understood, is sum of the two factors or components, but the total resistance is directly proportional to rho into S into V raised to power n. This is a empirical relation, proportional to. It is not equal to, proportional to, which means that more is the density. That means from freshwater to seawater the vessel goes, the total resistance will increase. It is proportional. Also proportional to S. S is the wetted surface area. S is the wetted surface area. The unit of measurement of area, because we are using SI units everywhere, all numericals we solve, we will be using SI. And that is why in the beginning only I said we will be very particular about the unit, what we are using in each formula. So I would request you to keep noting down the formulas. In some exercise book, keep just 2-3 pages at the end of the exercise book so that you have in chronological order all these formulas with units, so that when we use them in numerical, we do not forget the units to be used in that formula. So S in meter square. When I use the word capital V, this is the speed of the vessel. Speed of vessel over ground. Correct? This is what, and the unit is knots. All formulas, wherever I use capital V, it means it is the speed of the vessel over ground, and the unit of measurement is knots, which you are very familiar with, so I don't see any problem. However, please remember, wherever I use a small v is also speed, but in meters per second. Because SI unit, there is no scope of knots being used. It is speed in meters per second. So most of the formulas are in terms of knots, but when we calculate power, we will be converting that speed into meters per second. This we have to remember, and as we do the numericals, of course, I will keep reminding you, but nevertheless, just keep in mind. Now N here is the index. Now this index, it depends on type and speed of the vessel. Type and speed of the vessel. For slow speed vessels, vessel, N is taken approximately as 2. All right. This is just we have to remember. Mr. Froud did a lot of research and he established this relationship. Now coming back to this relationship that RT is proportional to rho into S into V. We can say from this relationship, what is S is the wetted surface area in meter square. I can also say, since it is a area in linear dimension, it will be meter into meter. Any area can be converted into so many L into L. So I can L to L square. Correct? And therefore I can also write L is proportional to S raised to power 1 by 2. 1 by 2 is square root. 1 by 3 will be cube root. Now we also know displacement can be written as proportional to L cube, and therefore I can say L is proportional to displacement raised to power 1 by 3. This is all based on linear dimensional analysis. And since I am not using any constant, it is all proportional to, it does not matter. I mean, we can write it like this. Only when we will convert into a relationship by replacing proportionality sign, we must introduce a constant. Using these two over here, I can say all right. So RT, which is here, is proportional to. So I'm just keeping it proportional to and keeping. All right. Now using the let me write it in the side just to get another. I'm just writing it here side in the side using these two. If S is proportional to L square, and L is proportional to delta raised to power 1 by 3. I can also say S is proportional to delta, putting a value of this L here, delta raised to power 2 by 3. Correct? Because this is L2, and replacing it by delta, I can say delta raised to power 2 by 3. So this is the one which I am using here. Keeping rho as rho, because rho is a constant, as far, I mean nearly constant. If I consider the density of the seawater nearly 1.025, I can say this is a constant, but I can replace S by delta raised to power 2 by 3. V raised to power n, if I take n as 2, as it is for the slow speed, I can say V square. This is RT proportional to. Now, what is power? Power P, or let me write full only. Power is equal to RT into V. Now, this I am using small v because power RT is a resistance in kilonewton and speed will be in meters per second. Why? Because if I can only use the units to see what power comes out to be, force in kilonewton, speed in meters per second, the whole thing becomes kilonewton meters per second. Kilonewton meter is the work done. Per second, rate of doing work is power. That is how power is total resistance into the speed. Correct? This is the basics about power. Power is rate of doing work. And work done is always force into distance. So force is kilonewtons, distance is meter. That is the work done per second will be the power. So RT into V represents the power. And therefore, I can say power P is, from this relationship, I can say power P is proportional to RT is this one into V. So RT is rho into delta raised to power 2 by 3 into V square into V, and that is how this will become V cube. So power, if I put equality sign, I have to use a constant, so I use say K delta 2 by 3 into V cube. This is the relationship we got, but we don't want to keep K here. Of course, rho is also there. I keep all the constants on the left, so I can put them all on the left hand side. So I'm shifting from here, coming here because space is less. So I can say a constant AC, which I have done by putting it here. 1 upon KR, K into rho will also be a constant. So I'm giving it a name AC, or admiralty coefficient, is equal to delta 2 by 3 into V cube, and power comes diagonally down below in denominator, power P or power here. This is the relationship which we call admiralty coefficient relationship. So admiralty coefficient is equal to displacement of the vessel raised to power 2 by 3 multiplied by V cube divided by power. So it is a relationship between power, displacement and speed of the vessel. Now, this relationship can be used to our advantage because I can, since left hand side is constant, which I am calling admiralty coefficient, I can use this relationship if I write it like this. Let us see on top. Delta 1 raised to power 2 by 3 into V1 cube divided by P1 will be equal to delta 2 raised to power 2 by 3 into V2 cube divided by P2. This is the relationship which we got. Now I can use this very effectively because if I know displacement of the vessel under one condition, when the vessel is moving at V1 speed, developing P1 kilowatt of power, I can calculate if I displacement changes from delta 1 to delta 2 and speed changes from V1 to V2, what will be the power? Or if I change the power from P1 to P2, what will be the change in the speed from V1 to V2? If I know V1, I can calculate V2. So this relationship helps us in calculating any one of the factors given in this relationship if I know the other factors. For example, if vessel is underway, we are in an open sea in the same voyage. So displacement, if it is not changing, I can cancel this. Delta 1 will be same as delta 2. If I change P1 to P2, and I was operating at 12 knots or 30 knots, I can know immediately what will be the new speed. So this is the relationship which is called Admiralty coefficient. So Admiralty coefficient is delta raised to power 2 by 3 into V cube over power. All right, so is it clear to everybody? Anybody has any doubt can ask.
तो ये जो लेफ्ट साइड में जब आपने प्रोपोर्शनल का साइन हटाया था, जहाँ पे पावर इज इक्वल टू के इंटू डेंसिटी के इंटू, सब वो गया कहाँ वापस नेक्स्ट टाइम जब आपने
it has come in this constant AC. See, अगर मान लो 5 है, 5 is a constant, 1 upon 5 will also be a constant, ना? So if this k into rho को मैं इधर ले आया नीचे और p को इधर ले आया, so 1 upon k rho will be equal to delta 2 by 3 v cube divided by p. So that is absorbed in AC. AC is a constant, is a Admiralty coefficient. It is a constant. So that this all has been absorbed in this because this is k is also constant and rho is also constant. ठीक है ना?
Yes.
We are assuming rho. We are assuming density is constant because even if it is not, it is not making so much of difference. Density will be nearly, seawater density will be nearly 1.025, maybe 1.024, 23, but we can say it is nearly constant just to, so that is the assumption made by us. So this is also constant, and by removing proportionality sign, we have introduced one constant. So if this is constant, 1 upon kr will also be a constant that we are calling as AC, and we can say AC is equal to delta 2 by 3 v cube over power. And that is how we got this relationship.
This formula will be using in numericals?
Of course, otherwise I will not be doing it. We will be using it in numerical. This is the first type of numericals we will be doing. Now, the important thing here is to know the units of measurement so that we don't make mistakes.
Excuse me, sir.
Yes, please.
Sir, you have the notes for explanation.
Pardon?
You have the notes for this explanation for this formula.
It is there in JK Dhar book. You can just go through that. I am doing it everything from JK Dhar.
Okay, sir. Thank you.
It is there. You can go through that. If you don't understand, then I am explaining over and above what is there in JK Dhar so that
So
it is.
We will get one numerical of this type in exam, right, sir? Only one, right?
No. It is not that you will get a numerical definitely from this. Total one numerical will be coming in your paper. It can be from this. It can be from calculation of consumption. It can be from calculation of voice consumption. It can be calculation of slip. Any of those. So as I told you, there are 4 or 5 topics on which the numerical can come. But one numerical only will be coming. So whichever comes, whether it is from Admiralty coefficient or it comes from fuel consumption or it comes from slip or power, we have to do that one. Only one numerical will come, and there is no choice also.
Oh, I think that will be a compulsory one, right?
Obviously, yes, that is mandatory. It is compulsory question. First one you have to attempt. So that is why my idea is to. Yes, please.
It's a failing question.
Pardon?
ये गलत हुआ तो ये मतलब इट्स अ फेलिंग क्वेश्चन. अगर ये गलत हो
अगर ये गलत हो गया तो 0 हो जाएगा ना न्यूमेरिकल में. लेकिन उसमें एक्चुअली इट इज नॉट दैट बैड बिकॉज If you have done numerical wrongly, that means your understanding of the numerical is wrong, and then you will get 0. But if you have done it correctly and you make a mistake in calculation, you will still get marks. So it is not exactly that. It is not that answer should be 14.52 और आपका भी 14.52 है तो भी आपको 25 मिलेंगे, ऐसा नहीं. अगर 14.4 भी आ गया, you will get full marks. Understood? Because you have done the steps correctly. So examiner is looking at whether you know it, you have done the steps correctly. अगर calculation में गड़बड़ी हो गया, maybe 1 mark or at the most 2 marks will be deducted. But out of 25, if you get 23 also is very good. Right?
So this EK is a 100 or 200 marks paper.
200.
And we need
25 marks का एक question है.
Okay, so we need 100 for passing, right?
Yes, yes.
Okay.
You need 100 for passing. And 25% of that is 25, this numerical. Okay, so now.
Sir, I have one doubt.
Yes, please.
Sir, in RT, there is a before this velocity we have taken in knots. And in the power, there one you use small v also, that is meter per second.
Okay.
So here you put the v cube. So before that, we have to change the units also.
No. No, why that I will tell you. If I am calculating power, suppose if I am calculating power using this relationship, power is equal to RT into V, and somebody tells me the value of RT, sorry, can I remove this whatever is written here so that it will be clear? So let me just erase this, just to explain that point. Discard and again coming back here. So my formula for Admiralty coefficient is delta, which is displacement raised to power 2 by 3 into V cube by power. Units in this formula, delta tons. Displacement is in ton. V. Speed is in knots. Power is in kilowatt. These are the units I am if I am using this relationship. However, if I calculate power using RT and V, suppose RT is given, total resistance of the vessel is 1000 kilonewton. Speed of the vessel V is 15 knots. Calculate power. Okay? Power will be equal to RT into V. This will be then equal to RT is 1000. V is here I have to put in meters per second. So 15 into 1852 divided by 3600. Knots, 1 nautical mile is 1852 meters and knot is nautical miles per hour. So per second I have to convert into 36. So this is the conversion. Here I will be converting these knots into, because I am calculating power in kilowatt. Answer is in kilowatt. But if I am using this relationship whereby I am using delta 1 raised to power 2 by 3 into V1 cube, P1 is equal to delta 2 by 3 into V2, because this is constant, so I can write this V2 cube divided by P2. Now if suppose displacement is same, vessel is underway and I am only changing power, so this gets cancelled. So what I get is V1 cube, or I can say V1 by V2 cube, V2 मैं नीचे ले आता हूँ, is equal to P1 by P2. यही बनेगा ना मेरे इस रिलेशनशिप का. इसमें जो है V1 is in knots, V2 is in knots, P1 is in kilowatt, P2 is in kilowatt. I don't have to change it. Suppose even if I change it also, then this will get cancelled. Suppose I use in meters per second, this also in meters per second, nothing will happen because they will get cancelled. But suppose I am only calculating using this relationship. Admiralty coefficient is given. Let us say AC is 420 or 425. So I can calculate power using this as displacement, this as speed, and divide by 425 will give me power. Understood or not understood?
Okay, sir.
ठीक है ना? तो ये ध्यान रखो, जब तक ये फार्मूला यूज कर रहे हो, as long as I am using this formula, these are the units to remember. Displacement in this equation is in tons. This V is in knots. Power is in kilowatt. But if I am calculating power separately using, if somebody has given me RT, then of course in metric kilowatt is kilonewton meter per second. That is the unit rate of doing work. So यहाँ पे मैं knots नहीं use कर सकता. I have to convert it into meters per second. Otherwise, the basic definition of power will change, ना? It is not kilonewton nautical miles per hour. ऐसा नहीं है. Kilowatt is 1 kilowatt is 1. If a 1 kilonewton force is applied, moving the object to 1 meter distance, we will say 1 kilonewton meter work has been done. And if it is done in 1 second, then we say 1 kilowatt power has been used. Clear है कि नहीं clear है? कोई doubt है? पूछ लीजिए. लेकिन ये साथ साथ लिख लीजिए. Just write it down that these are the units, because I have seen people making mistake in units only. फॉर्मूला तो फिर भी ठीक ठाक याद रह जाता है, लेकिन यूनिट्स जो है साथ साथ लिखते रहना चाहिए कि इस फॉर्मूले में ये यूनिट है, बाकी कुछ याद रहे ना रहे. Is it okay? Clear? So far clear? All right. Hoping it is clear.
लिख लेते हैं सर 1 मिनट.
Sorry, हाँ लिख लो. एक चीज और मैं बता दूं आपको. अब वैसे तो you people know better than me about this change in displacement, but if the vessel is underway on a voyage, we do not consider change in displacement because of the fuel consumption. Please remember, because if I say the vessel we have changed the speed from V1 to V2 during the voyage, then delta 1 and delta 2 will remain same. Don't start thinking अरे consumption भी तो हो रही है तो displacement change हो जाएगा. नहीं, we are not considering that. Displacement change will be only considered if you load cargo or discharge cargo. Okay, अगर मेरा 10,200 टन था डिस्प्लेसमेंट और अब मैंने उसमें दिया हुआ है कि डिस्प्लेसमेंट चेंज हुआ क्योंकि हमने कार्गो लोड कर लिया, अब मेरा 11,500 हो गया, तब मैं डेल्टा 1 ये हो जाएगा, डेल्टा 2 ये होगा. लेकिन अगर वॉयज में इसका कोई जिक्र नहीं है कि हमने कुछ कार्गो लोड किया या नहीं किया और कंजम्पशन तो है, जब जहाज चल रहा है तो कंजम्पशन होगी, उससे भी तो डिस्प्लेसमेंट चेंज हो रहा है, वो हम नहीं इसमें कंसिडर कर रहे हैं. सो देन डेल्टा 1 इज सेम एज डेल्टा 2. करेक्ट? क्लियर है ना? जस्ट कीप इन माइंड.
सर अगर हम कोई फ्यूल वगैरह लेते हैं तो चेंज होगा ना?
हाँ, अगर उसने न्यूमेरिकल में मेंशन किया है, उसने कहा कि वी हैव बंकर्ड 5,000 टन और 4,000 टन ऑफ बंकर, फिर चेंज हो जाएगा. लेकिन अगर उसने कुछ बातचीत नहीं की इस बारे में और आपकी वॉयज पे चल रहा है और वो कह रहा है डेली कंजम्पशन इज 30 टन पर डे, उस पर आप सोचना मत शुरू करो भाई 30 टन पर डे हो गई, 10 दिन की वॉयज है तो मेरा इतना डिस्प्लेसमेंट चेंज हो जाएगा. नहीं, don't that will not be considered.
That will affect my fuel only, not my displacement.
Correct. So only if they mention that vessel called port and displacement change from this to this, then we know that delta 2 is this much. But don't start calculating yourself कि consumption हो गई तो इतना change हो जाएगा मेरा, वो नहीं करना. Okay, so any other question? So this was the preliminary. Have you written down?
Yes sir.
All right. So since the
ये एडमिरल्टी कोएफिशिएंट क्या क्यों कैलकुलेट कर रहे हैं हम लोग, मतलब रीजन क्या है इसके पीछे?
This is for approximate calculation of the power or other factors. अगर मेरे को ये पता है let us say as I gave you example, this is Admiralty coefficient equation ना, this is constant, that is why it is equal to this is equal to delta 3. अगर मान लो voyage में मेरा delta 1 delta 2 चेंज हुआ नहीं, मेरे को V1 से V2 मेरे को स्पीड बढ़ानी है 10 नॉट से 15 नॉट. अब मुझे ये कितनी पावर चाहिए, मुझे पता चल जाएगी कि इतने किलोवाट पावर चाहिए. अगर इतने किलोवाट पावर चाहिए तो मेरी कंजम्पशन कितनी हो जाएगी. आई नो पर यूनिट पावर SFOC पता है मेरे को, पर यूनिट पावर इतनी कंजम्पशन होती है तो मुझे पता चल जाएगा मेरी कंजम्पशन अब इतने से इतनी हो जाएगी. मेरे पास फ्यूल है कि नहीं है या जो भी रीज़न है उसके लिए आई विल नो व्हाट इज़ द पावर रिक्वायर्ड. और इफ़ आई से अगर मेरी पावर P1 से P2 हो जाए, 10,000 किलोवाट पे इंजन चल रहा है, मैंने उसको 15,000 कर दिया, व्हाट विल बी द स्पीड आई गेन. 15 करने से कितनी स्पीड चेंज हो जाएगी मेरी, ये पता चल जाएगा मेरे को. और स्पीड मुझे तो चाहिए पता ही करना है, क्योंकि मेरे को पहुंचना है ना कहीं पे, वॉयज में कहीं तो पहुंचना ही है ना मुझे. सो आई वांट टू नो, अगर मेरी ये स्पीड ओके है आई विल गो फॉर दिस एंड वाइस वर्सा. सो एनी वन पैरामीटर विच इज नॉट नोन आई कैन कैलकुलेट.
ओके सर,
ठीक है ना. और सबसे इम्पोर्टेंट
वैसे हम कैलकुलेट करते हैं कि एक दिन की कितनी कंजप्शन है और मैक्सिमम स्पीड कर लेते हैं और उस हिसाब से कर लेते हैं
वो तो, लेकिन ऐसा तो नहीं है. मेरे को तो ETA दिया हुआ है यहाँ पे, मेरे को पहुँचना है सुबह 7:24 पे. मेरे कार को बुक है, कंटेनर सारे यहाँ वेट कर रहे हैं मेरे. आई मस्ट रीच हियर, सो आई नो दिस डिस्टेंस. आई मस्ट कैलकुलेट व्हाट इज द स्पीड आई शुड गो विद. इफ आई नो कि मेरे को 15 की जगह 15.5 चाहिए मुझे, तो मैं कुछ फैक्टर ऑफ सेफ्टी रख के कहूँगा चलो 16 नॉट चाहिए मुझे. 16 नॉट से मैं देखूंगा ये मेरा डिस्प्लेसमेंट कितनी पावर चाहिए, इतनी चाहिए, इतनी पावर से कितनी कंजम्पशन होगी, इतनी होगी, उतने बंकर होने चाहिए मेरे पास. ठीक है ना. सो वी कैन यूज इट इन वेरियस वेज. दिस इज जस्ट वन एग्जांपल.
तो अगर डिस्प्लेसमेंट सेम है तो भी यही फॉर्मूला यूज होगा, अगर डिफरेंट है तो भी यही होगा, राइट? डिपेंड्स कि हमको क्या
yes. अगर डिस्प्लेसमेंट सेम है तो दिस विल कैंसिल आउट. अगर डिस्प्लेसमेंट नहीं है देन आई विल पुट द वैल्यू ऑफ डिस्प्लेसमेंट हियर.
ओके
फॉर्मूला यही है.
देन उस केस में फिर उनमें से आपका डिस्प्लेसमेंट चेंज हो रहा है तो फिर मतलब फिर आपकी V1 या V2 सेम रहेगा, फिर कुछ कैंसिल आउट होने के लिए ऐसा कुछ?
कैंसिल कुछ नहीं करना हमें. अगर डिस्प्लेसमेंट पता है यहाँ 10,000, बाद में यहाँ पे ये एक वॉयज का डेटा है
ना सर, डेल्टा 1 डेल्टा 2 की सर.
डेल्टा 1 डेल्टा 10,000 था ना, मैंने 5,000 टन और किया तो डेल्टा 2 क्या हो गया. ये तो मेरी पहली वॉयज मैंने करी इस डिस्प्लेसमेंट से, ये स्पीड थी, ये थी. अब मेरा 15,000 हो गया तो मैं यहाँ दिस AC विल रिमेन सेम, तो दिस इज इक्वल टू दिस. यहाँ डिस्प्लेसमेंट की वैल्यू डाल दूंगा मैं. स्पीड यहाँ मेरी 15 नॉट से किया था, सो आई कैन कैलकुलेट कि मेरी स्पीड कितनी होगी. अगर सेम ही पावर करूं तो P1 P2 सेम हो जाएगा, और V1 पता है तो V2 निकाल लूंगा. अगर मेरे को V1 V2 पता है तो आई कैन कैलकुलेट की पावर कितनी होगी. एक फैक्टर मुझे, एक पैरामीटर अननोन रहेगा तो आई कैन यूज दिस इक्वेशन टू कैलकुलेट दैट. एनी वन इवन डिस्प्लेसमेंट. अगर बाकी सब चीजें पता है, V1 स्पीड थी, V2 कर दी, P1 से P2 पावर हो गई, what is the new displacement I can calculate using this, because this all is equal to AC, Admiralty coefficient is equal to this. That is why we got this relationship. ठीक है, क्लियर?
यस सर.
और सबसे इम्पोर्टेंट चीज़ ये है कि हमें एग्जाम में करना है, बाकी कहीं करे ना करे. अगर न्यूमेरिकल आया है और ये सब डेटा पता है, वी शुड बी एबल टू सॉल्व इट. 25 नंबर. हाँ जी बोलिए.